Hello dear students, let's again see the second decision property of CFG. Just see, first property we saw was membership, and membership problem is solvable. There exists an algorithm. Second is finiteness property. The question is the language generated by the given context-free grammar, is it a finite language? Is the question. That means L, language generated by this grammar, is it containing finite number of strings, or is this a infinite? Is this an infinite set? Is the question. We will again use Chomsky normal form to prove whether the language is finite or not. As you know, in Chomsky normal form, the right hand side can contain exactly two non-terminals, and the right hand side can also contain a single terminal. Now what we do is that we represent each of the non-terminals by a vertex of a graph. Just check, I'm just drawing a graph with vertices, okay, and you know that the non-terminals are S, A, B and C, okay. Now what is S deriving? S is deriving AB. So we will say S derives AB means we will draw a directed edge from S to A and S to B. What that means is S is deriving A followed by B, but S is deriving A followed by B. So what we do is, instead of drawing directed edge to both the vertices, we will show that S derives capital A followed by capital B. Please try to understand. Just see why A to B is connected, because S derives A and that is followed by B, okay. So this can be read as S derives AB, okay. Further, S derives A, check the second production. Now we don't deal with this terminals, the productions which generate only terminals, so just leave it. We don't represent it in the graph. Now A derives CS. How do you represent this? A derives C followed by S. Just check this. A derives C followed by S, correct? Now we don't represent this production where only a single terminal is generated. We don't represent this where a single terminal is generated. Now observe the resultant graph. This graph has cycle. The cycle is S to A to C and C to S. Again S to A. Just check. There is a cycle here. There is a cycle. And if the graph for CNF, we have drawn the graph, has cycle, then the language LG is infinite. So this can be an algorithm. What do you say? Constructing a graph can be an algorithm or a method by which we can check whether the language generated is finite or infinite. If graph has cycle, then the language is infinite. As another example, just check. I am writing a very simple CNF. Let's say I have S derives AB, okay. A derives, let's say A, and B derives B. Very silly, very silly. Actually, there is only one string generated by this grammar, AB, that's all. But then, what will be the graph? Just check. S derives AB, so S derives A followed by B. But we don't use this productions at all. Now, this is the graph, and this has no cycle. Then the language generated is finite. And indeed, the language generated is finite. In this language, there will be only one string AB, that's all. Because S derives AB and in next step, A gives A and B gives B. This is the only string in this language. So this is finite. The point is that finiteness property is solvable. There exists an algorithm in which we can draw a graph and check for cycles. If there exists cycle, then we say that the language is infinite. I hope you got this, and we will return to the decision property in next video, where we will see another decision property. Thank you very much.